Hello Internet, welcome back to the workshop. The first thing most people do when they get one of these import mini lathes is they upgrade the headstock bearings. The typical replacement or the typical upgrade is an angular contact or a tapered roller bearing. One drawback of those replacement bearings is that unlike the original bearings, they're not sealed. They require lubrication. In today's video, I'm going to show you how I modified my headstock to add an oil bath for lubrication. If that interests you, stay tuned. We'll get started. Adding an oil bath to the headstock, it's not difficult, but it does require some fabrication. I removed the gears, the belt, and the guards to give you a better look at what modifications are required. So first, you need a way to keep the oil in the headstock. You'll need oil seals on the primary shaft, and if you've got a 2-speed headstock, you'll need oil seals on the intermediate shaft, and you'll need to seal the selector shaft. Once you have the shaft sealed, you'll need to seal the headstock to the bed. And last, you need to add fill and drain plugs so you can change the oil. So let's take a look. I want to show you how I made each one of these modifications to make this work. I want to start with the main shaft oil seals. My lathe came with a pair of plastic bearing retainers. Unfortunately, these are not going to work for holding a seal. Instead, I bought a pair of aluminum bearing retainers. I got these on eBay. If you can't find these, you'll have to make them yourself. The bearing retainer is designed for this single-speed headstock. If you're using it on a 2-speed headstock, you'll have to modify it to accommodate the intermediate shaft and its bearing. The way I did that, I mounted it off-center on the rotary table, and I used the mill to cut that clearance. That worked really well. The bearing retainer fits in there perfectly. The main spindle shaft is smaller on the drive side than on the chuck side. It measures 28.3 millimeters on the drive side and 48 millimeters on the chuck side. The oil seal that I could find that would work with these two sizes is 60 millimeters on the outer diameter. To fit the oil seal in the aluminum bearing retainer, I put it in the mill in the rotary table and I milled it out to 60 millimeters on the ID. I could not find a 60 by 28 oil seal. The best I could do was 60 by 38. So I made a spacer that fits in here that the seal rides on. I turned it on the lathe to 38 millimeters OD to fit the seal. The chuck side, it didn't require any spacers. I was able to find a 60 by 48 oil seal, which works perfectly. Now that the main shaft is sealed, we need to work on the intermediate shaft. If you have a single speed headstock, you can skip this section. The intermediate shaft sits in the oil bath, so we'll need to seal it too. It's a little less straightforward than sealing the main shaft. The bore on that headstock, it's a little bit over 25 millimeters. It's a rough cast bore. I thought maybe I could get some 25 millimeter seals and glue them in. So I ordered a pair of 12 by 25 oil seals. They fit in there too loosely even to glue them in, so I had to abandon that. To fit a 20 millimeter seal in a 25 millimeter bore, I made what I'm going to call a seal carrier. I started with 1-inch aluminum stock. I bored the center to 15 millimeters and then I cut a groove to support a seal. I then pressed that retainer into the headstock and tapped the new oil seal into place. Now that we've got those oil seals in place, the intermediate shaft is sealed. Here's a better look at how that goes together. The seal carriers are pressed into the headstock. The shaft is fitted. The oil seals are tapped into place, and then the bearings are installed. The last thing to seal on the headstock is the selector shaft. If you have a single speed headstock, you don't have to worry about this either. I mounted the shaft in the mill on the rotary table, and I used an 1/8 inch end mill to cut a groove for an O-ring. When the shaft is installed and tightened down, the O-ring is compressed against the headstock, sealing the shaft. So that's it for the shaft seals. Now let's focus our energy on the drain plugs. I drilled 2 holes in the headstock, one for a fill plug and one for a drain plug. This is the fill plug. I drilled it right in the middle of the headstock. I did that because there's two gears in here and I wanted to make sure it didn't hit them when I put the plug in. The plug is just an M10 by 1.5 bolt. I cut it down so it wouldn't protrude into the casting. This is the drain plug. I drilled it about a ½ inch up off the bottom of the headstock. I did that so that when it's installed, there's enough clearance to clear the V-groove in the lathe bed. The inside of my headstock was quite rusty. I used electrolysis to remove the rust. That freed up a bunch of casting sand. I scraped that out with a screwdriver. The inside of the casting is quite porous. I used some air-cured epoxy to seal the inside of the headstock. Now that the headstock is sealed, we need to seal it to the lathe bed. If you look at your lathe bed, there's two things here to notice. One is this groove, and two is that the V is flat on the top. Both of those are going to be a problem when we go to seal the headstock. I cut a length of square profile O-ring and I used it as a gasket for the slot in the bed. I then applied a very liberal coating of silicone sealant to the headstock and bolted it in place. You have to be careful here though. You need enough sealant to seal the headstock, but not so much that it affects its alignment on the bed. The oil level in the headstock is right at the middle of these grounding holes. It sets so that the gear on the intermediate shaft, as it rotates, it flings oil all around inside the headstock. That lubricates the bearings and that lubricates the gears. Oil-wise, I'm using some 15 weight 50 engine oil that I had around for my motorcycle. I don't know that it really matters what's in here as long as it's got a reasonable viscosity and it's rated for some sort of a gear loading. After all that work, I put the lathe back together. Here's how it turned out. This project turned out really well. I've been using it like this for the last year. A couple months ago when I did the treadmill motor, I had the headstock off. The oil that came out still looked new and the gears are in really nice shape. I haven't had any trouble with leaks. I've been really happy with it. I've noticed that the headstock runs quieter and it seems to run cooler. If you've replaced the bearings or you've installed metal gears, I think this is a really worthwhile upgrade. If you're subscribed to my channel, I want to say thank you. It's very much appreciated. If you're not subscribed and you enjoyed this video, I put out content like this just about every week. So I'm going to wrap this one up, guys. Thank you for watching.